All right, so looking at polynomials. Today we will look at polynomials. So this is pretty much the most straightforward type of algebraic expression that we have. This is what you started learning when you first started getting introduced to variables and that type of thing. So a polynomial is one term or a collection of terms and the variables on exponents are whole numbers okay? And what we want to make sure is say that we've got no radicals, no variables under radicals, and we are going to say that there are no variables in denominators. Okay, so this is just another way of reiterating that our exponents have to be whole numbers. So what are whole numbers? Whole numbers are your counting numbers that start with 0. So 0, 1, 2, 3, 4, 5, and it goes on and on and on, and up and up and up. So we've got one term or a collection of terms. The variables on your exponents are whole numbers. No variables under radicals, and no variables in denominators. So that's what we've got to be careful of. Now, when we do these, we want to put things in descending order. So we want big exponent to small exponent. So we start with the biggest. And then once we organize these things, what we are going to do is we are going to add them, we are going to subtract them, and we are going to multiply them. We will not divide till later. Okay, but we're going to add, subtract, and multiply these things together. So our strategy is going to be to simplify as much as possible, and then we're going to combine like terms, and then we're going to go from there. So what I want to do is, first of all, we're going to look and see what some of these things are. Can it be a polynomial? Can it not be a polynomial? And then we're going to talk about the degrees and that type of thing. So let's say if I've got a negative 5x to the 16th. What I'm concerned about is that x to the 16th. Okay, so I do have an x to the 16th. And so is that thing in a denominator? No. Is it underneath a radical? No. Is it a positive counting number for your exponent? Yes, it is. So I've got an x to the 16th. This is one term. So I'm going to call this a special type of polynomial, and I'm going to call it a monomial. Mono meaning one. Okay, so this is one term. It's a monomial. So the degree of this particular, or of any polynomial, is going to be the largest degree that it has. Well, this only has one term. Okay, so remember, terms are separated by pluses and minuses. So this is glued together with multiplication. And so this is one single term, and its largest exponent is a 16. So the degree of your polynomial is 16. Okay? So it is a polynomial. In fact, it is a special type of polynomial. It's a monomial, and its degree is 16. So let's try another one. I've got a negative 9 z to the 6th minus 2z to the 3rd plus 4. So my question is this a polynomial? So I'm going to look at my variables. I've got a z to the 6th. I've got a z to the 3rd. And there's actually a z to the 0 here that I'm too lazy to write. Okay? Because remember, any number to the 0 power is 1. So there's a z to the 0 that I'm too lazy to write. So my question is, do I have variables in denominators? No. Do I have variables under radicals? No. And just in case you forgot, a radical looks like that. Okay? Do I have variables under radicals? No. So is this a positive counting number? Yes, it is. Is this a positive counting number? Yes, it is. Is this a positive counting number or 0? Yes, it is. So this is a polynomial. Now I would like to know how many terms it has. So I'm going to look at this, and I've got this one, and then all of a sudden I change using addition subtraction, and then I change using addition subtraction. So I've got 3 distinct terms. So we're going to call this a trinomial. So 1 term is a monomial, 2 terms is a trinomial, 2 terms is a binomial, and then 4 terms and above, we just say how many terms we have. So we'll say a 4-term polynomial or something like that. They don't have special names. All right, so what is your degree? Look for your biggest exponent. So I've got a 0, a 3, and a 6. What is your biggest exponent? My degree is going to be 6 because that is my biggest exponent. I thought I wrote 16. That's my biggest exponent. Okay, so it is a polynomial. So let's try another one. I have a 19, a to the 4th b squared, plus a 13, a to the 9th, b to the 5th, minus 19, b to the 6th, plus 10, b to the 7th. So my question is, first of all, is this a polynomial? So I look at this, I see no variables in denominators. I see no variables under radicals. So now check and make sure your exponents are okay. Positive 4, good. Positive 2, positive 9, positive 5, positive 6, positive 7, we're good. Okay, as long as it's from 0, 1, 2, 3, 4, 5 and goes positive. So this is good. I would like to know what kind of a polynomial this is. So I've got these terms that I can figure out where they are by looking for my pluses and my minuses. So I've got 1, 2, 3, 4 terms. So yes, it is a polynomial. It's 4 terms, so he doesn't have a special name. It's not a monomial, binomial, or trinomial. But I would like to know the degree. And so now there's a little bit of excitement going on because I got 2 variables. So I'm just going to add up the exponents on my variables. So a 4 and a 2 gives me a 6. A 9 and a 5 gives me a 14. That gives me a 6, and that gives me a 7. So my biggest answer is a 14, so my degree is 14. Okay? Degree of 14. So now we're going to start messing with these things and try and find out what we can and cannot put together. So I would like to simplify this expression. I've got a 5t plus 15 minus 5. So when we combine like terms, what I'm doing is I'm counting. Addition, subtraction is just counting. Okay, so this tells me when all was said and done, I counted up 5 t's. Do I have any other t's? I do not. So I've got 5 t's here. I've got a plus 15 here, and I got a minus 5 here. So I have a total of 5 t's, and then these are like terms. These are just constants. So if I'm done with my 5 t's, I've got 15 minus 5 is 10. So that ends up being a plus 10. That is as far as I can go. I cannot make that into 15 t's because you're telling me how many t's you have added together here. So I've got 5 t's here, and I've got just 10 sitting right here. So this is your answer. That is simplified. So just technically, this is a polynomial, and more technically, it is a binomial, and your degree is a 1. Okay, because remember, I'm too lazy to write that exponent of 1. Okay, so let's try another one. I've got a 5 plus 4 times s minus 3t. So the first thing I see is I've got some work to do. Those parentheses, as soon as I see parentheses, I've got something I got to do. Okay, I want to get rid of the parentheses. So can I do anything on the inside? I cannot. That says s minus 3t. They both don't have s's and they both don't have t's, so I cannot put those together. So that's as far as I can go. So let's go back to order of operations. There's no parentheses. There's no exponents. Now I need to do multiplication and division. So we've done this before. I've got this 5 sitting here. And now this positive 4 is going to distribute out to both terms in the parentheses using multiplication. So this 5 is going to drop, and then I have a positive 4 times s is positive 4s, and a positive 4 times negative 3t. So I'm going to cover this up just a little bit. A positive 4 times a negative 3 is a negative 12, and then that t is going to come along for the ride. So I've got a negative 12t. So now I need to stop for a second and look. Do I have any additional like terms? I've got a 5, I've got a positive 4s, I got a negative 12t. There's no s's I can put together, there's no t's I can put together, there's no constants I can put together. So I'm done. That's as simplified as it can get. How many terms do I have? I have 3 terms. So what is this? This is a trinomial. Okay, and then what's the degree? This degree is 0. This degree is an s to the first, so this is a degree of 1. And this is a t to the first, so this is a degree of 1. So this is a degree of 1. You just have different variables representing it. So this is going to be your final answer. All right, so let's simplify some more. I've got 2p squared plus 4p to the third, and then minus 6p squared, and minus 9p to the third. Okay, so there's nothing I can do with the exponents. Okay, there's no distribution, there's nothing like that, so I need to move on. There's no parentheses, there's no grouping symbols, anything like that. So what do I have? I've got this term, I've got a plus 4p to the third, I've got a minus 6p squared, and I've got a minus 9p to the third. So I've got 4 terms right now. I wonder if I can put any of them together. So when I look, how many p squareds do I have? I've got 2 here and minus 6 there. So I can put my p squareds together because remember addition subtraction is just counting. So if I have 2 here and I take away 6 here, that means I end up with a negative 4 p squared. That's how many p squareds I have. Okay, what about p to the thirds? How many of those do I have? So I've got positive 4p to the third, and I've got negative 9p to the third. Okay, so how many p to the thirds do I have? Don't change your exponent because you're not multiplying. You're telling me how many you have. So I have 4p to the thirds minus 9p to the thirds means I end up with a negative 5 or a minus 5p to the third. So when I've simplified this, I end up with a binomial. And what is his degree? His degree is 3. So when you're adding, subtracting, do not change your exponents. Okay? Let's try another one. I have a p times 3p minus 6. And then I have a plus 4 times 7p minus 5. Okay, so what is this going to give me? First of all, what do I need to do? I need to get my papers is what I need to do. All right. What do I need to do to this? So I notice there's no exponents. I do have grouping symbols. So is there anything to be done on the inside here? No, I cannot put those together because he has p's and he does not. Okay, can I do anything over here? No, he has p's, he does not. So I can't put those together. So then why do I have grouping symbols? Well, it looks like I've got multiplication going on. So I've got 2 sets of multiplication. So I'm going to take this p times those 2 terms, and I'm going to take that 4 times those 2 terms. And I'm going to be careful with my signs. So I have a p times a 3p means now I've got exponents because I've got a p times a p. So how many p's are you multiplying together? 2. Okay. P times a negative 6 gives me a negative 6p. And so now I'm done with this part, so now come over here. I've got 4 times 7p gives me 28p, and then 4 times negative 5 gives me negative 20. Okay, so I would like to look and see if I've got any like terms. So I've got this term minus this term plus that term minus that term. So do any of them match? Can I put any of them together? There's no other p squared, so he's done. And then how many p's do I have? 28p's minus 6p's is 22p's. And it's positive. It's a positive 22p. And there's no other constants, so I've got a minus 20. So again, addition and subtraction is counting how many you've got of something. So you're telling me how many p squared you got, how many p's you got, and how many p to the zeros you have, or how many just constants you have. So what did we end up with? We ended up with a trinomial. He's in descending order, and the degree of this trinomial is 2, because that's your biggest exponent. All right, so let's try one more, and then we'll go to a second video. So what I have is a negative y times y squared minus 7. And then I have plus 6y squared times 2y minus 6. Okay, so what do I have? First of all, look inside your parentheses. Can I put those together? No, he has y squareds and he doesn't. Can't put them together. He has y's, he doesn't, so I can't put them together. So then I look, in fact, I've got parentheses. I looked inside. Is there anything to do on the outside? There's no exponents or anything, so move on to multiplication division. That is the purpose of these parentheses right now, is it's telling me to distribute what's in front to everything on the inside. Okay, so I'm going to take this negative y first. I'm going to be careful with my signs. So a negative y times y squared is going to give me a negative y to the third. How many y's are you multiplying together? There's 1 here and 2 here, so I got 3 total. I've got a negative y times a negative 7. So a negative times a negative is a positive, and that gives me 7y. So I'm done with that first chunk. So move over to the next chunk. I'm leading off positive. So I've got a 6y squared times a 2y. So 6 times 2 is 12. And then y squared times y means how many y's are you multiplying together? 3 y's are being multiplied together. So that's a y to the third. And now take your positive 6y squared times your negative 6. So positive 6 times negative 6 is negative 36. And then y squared, there's no additional y's, so he just stays y squared. So now I need to see if I can put anything together. I've got y to the thirds. And if you'll notice, when I group these together, I pay attention to the sign on the left. Okay, so I group up whatever the sign is on the left. I don't care about the sign on the right. So I've got negative y to the third. Do I have any other y to the thirds? I do. I have 12 of them right here. So 12y to the thirds minus 1y to the third. Remember, there's a 1 right there that I'm too lazy to write. Means how many y's to the third do I have? I have 11 y to the thirds. Okay, so I'm done with this one, and I'm done with this one. So what's next? Well, I'm going to go ahead and start dropping my exponents down. So I've got a y3. Let's do a y2. So there's no other y squareds, so I'm just going to rewrite him, being careful to take his sign with him. And then I've got a positive 7y. So what do I have? I have a trinomial, and I have a degree of 3. Okay, so we will pick back up and finish on another video.